Alright, so now let's talk about describing distributions using words and statistics. We'll get to the definition of statistics in a while. It basically means a number that describes the whole distribution, or something about the whole distribution. So when describing a distribution, first of all, you could describe it as either unimodal or bimodal. Either it has one focus or it has two sort of focuses. In this case, there's two focuses, so this is bimodal. On the box plot, you can't see if it's bimodal or not. Sometimes it's not. If they don't give you information to say which one it is, don't bother commenting on it. There's skew versus symmetry. Either the distribution is symmetric or it's skewed. To get to that, first of all, I'm going to have to describe mean and median. So mean is the average, median is the halfway point. You guys know that, I hope, from way before. So you describe the center, and then you describe, you can also describe how spread out things are. And there are several things to do that. Range isn't very often used. It's the distance between the biggest and the smallest, 98, but in this case, in statistics, you won't be using it much. At least not in AP stats. Because there's other things that are used more often to describe just how spread out the data is. Something used sometimes is interquartile range because it's fairly visible in box plots. It describes how far apart the first and third quartiles are. So it's basically the range of the middle 50% of the data. The thing about regular range is it's very sensitive to one person who makes a ton of money or one person who makes absolutely no money. And so the fact that you have one person way out there can seriously affect the range. But when you're looking at the middle 50% and looking at how spread out those middle 50% are, that gives you a much more reliable feel for about how spread out things are, because it's looking at the middle of the stuff. How spread out is the middle as opposed to how spread out are the very extremes. Yeah, so interquartile range is often used there. In this case, it's 36. Standard deviation is more complicated. You'll use calculators to figure that out. But it's basically the average distance from the mean. So let's say in this case, the mean income is 42,170. Standard deviation would take how far each other thing is from that number and run it through a formula. And we'll get to the formula in class. You'll need to be able to look at it, but you probably won't ever calculate it using the formula. You'll calculate it using a calculator. I'll show you how. And it's not a straightforward average, but it is a more complex averaging formula. It has to account for certain things before, that mean you can't take a straightforward average of the distance from the mean. Anyway, standard deviation is very often used in this course. And here I would guess that the average distance from the mean is probably about 24 or so, although I can't tell because I don't know where any individual person is. Yeah, you couldn't calculate standard deviation from either of these because you don't know where any individual dot is, except for there being one dot at 0 and one dot at 98. You can't even be sure if there are, if these are actual dots, because it might be that the average lies right between 2 points, and like one is 31 and one is 33. And then you would average those two to get the, yeah. Okay, so let's talk about skewed distributions versus symmetric distributions. If I looked at a distribution and it looks the same to the left as to the right, then it is symmetric. This doesn't look the same to the left as to the right. There's this sudden peak on the left and there's this trailing off on the right. So this distribution is not symmetric. Does that make it skewed? Not necessarily. Skewed means something else very specific. Skewed means from the mean, from the center, is it farther to the left to reach the last point, or is it further to the right to reach the last point? So, in this case, if the mean was, 60, 60 is a lot closer to 98 than it is to 0. So this would actually be skewed left in that case. it's how the side where the last value is further out from the mean. That's what skew officially means. People often confuse it with bias because they say it'll skew the results, but that's a terrible misuse of words. Don't ever do that on the AP. Skew means the furthest extreme on the right is, if you say it's skewed right, then you say then what you're saying is the most extreme thing on the right is way further away from the mean than the most extreme thing on the left. If you say it's skewed left, that means there's like one person earning negative $100,000 or something. And that has nothing to do with, like, things don't skew let's not get into it. People usually use the word, they say, like, if you don't ask any people with, like, dreads, then that will skew the results. No, that will bias the results. Alright, and lastly, outliers. So, outliers are points that are way beyond what's normal for everything else. So, is this person who earns like $98,000 a day an outlier? To some extent it's a judgment call, although there is a rule that we teach you guys to decide whether something should be called an outlier, whether it's different enough from everybody else to be considered like playing by different rules, or maybe we should look into that's suspicious, or something like that. Is this person an outlier? The rule is, if a point is beyond 1.5 interquartile ranges from the middle two quartiles, then it is an outlier. So first of all, we have to figure out what the interquartile range is. Over here, it's 36. 1.5 interquartile ranges would be 54. So with 1.5 IQRs being 54, is this point more than 54 away from 68? No, they're only 30 away. So even that is not an outlier. It would have to be, this plus this would be 122. Anything beyond 122, if there was anybody who made more than 122, they would be an outlier, and they would probably be added to the graph as like, oh yeah, and there's this person who's an exception way out here. On the other hand, 54 less than 32 would be negative 22, so unless somebody was making less than negative 22, they would be considered an outlier on that side. So outliers are often drawn in as little extra marks beyond the end, which terminates at the last person who is not an outlier. Some graphs will include those, generally this is how it's drawn. Alright, next we'll talk about symbols, and, what I mean is, you'll see symbols in a second.